My name is Dick Rogers, entomologist with Bayer Crop Science. I have been keeping and studying honeybees since the early 1970s. I'm very pleased to be collaborating with professors and students at the Center for Analytics, Research, and Education at Appalachian State University. We are working on technology for advancing digital apiculture. Over the past almost 35 years, as a bee industry advisor, I have always struggled with customizing management recommendations for different regions. However, my experience with managing honeybee colonies from Newfoundland, Canada, to Southwest Arizona, Florida, Midwest US, and North Carolina over the past 20 years has really made me aware of the different management practices and timings needed in different regions. The tool we are going to describe to you today is used for visualizing weather from the perspective of the honeybee colony. The ultimate goal is to provide a tool to beekeepers that will help them make climate-smart decisions that will improve the health of honeybee colonies. We are investigating using the honeybee behaviors of flight and clustering as key indicators of how honeybees react to seasonal and climate factors. Here are a couple of very simple definitions for flight and cluster hours. Flight hours are the number of hours during daylight when conditions are suitable for honeybee flight. Cluster hours are the number of hours when ambient temperatures are below the average temperature for clustering. The definitions were used to develop algorithms for calculating flight and cluster hours. The algorithms were originally based only on threshold temperatures and actual temperature data. However, for the prototype tool, rainfall and wind have been included because they affect honeybee flight and are related to climate change. Now I would like to introduce Manuel Gutierrez to explain how he used freely available weather data to develop a prototype tool for visualizing what we are currently calling bee weather.
Well, I appreciate the introduction, Dick. And before I begin, I just want to say thank you for giving me the opportunity to work on this project. It's been a wonderful experience, and it is also great to be presenting alongside you today. And I'm not going to waste any time, and I just want to hop right into this because I'm really excited to talk about what we've been working on all this summer. Now, you already have an idea about what flight and cluster hours are and how measuring these can have importance to beekeepers. And I'm here to speak about our brand new interactive dashboard that helps monitor both flight and cluster hours for beekeepers around North Carolina. Now let's get started here with a brief introduction on what we needed to achieve this dashboard. And don't worry, we'll spin through a live demo shortly after. I know I'm excited to show you. So let's begin with addressing the data that we needed for the project. First, as you may have gathered from Dick, what constitutes a flight or cluster hour depends on various weather factors such as temperature, rain, and a few others. Now, we sought out to get hourly weather data for counties in North Carolina for the previous 5 years. The source we used was the NOAA ISD database, which is essentially weather readings from airports. And this is exactly what we needed because it was well vetted. Now, the NOAA data didn't have flight or cluster hours as a field, so I was to calculate those based on values in the data. This was our feature engineering stage. And without getting too technical, the language that we used to take care of scraping, cleaning, and feature engineering the data was Python. And after the data was clean, it was time to present it where anyone could interpret the results. So for this, we utilized Tableau to visualize the data as it would be a critical component to meeting our end goal, which is to publish for any curious beekeeper to find. And by using Tableau, we can embed the dashboard into a web page for anyone to view. With all that being said, though, I think it's about time that we get into the demo. All right, now what you're looking at here is our flight and cluster hours dashboard. As you can see, it's separated into two sections, one for flight hours and the other for cluster hours. Now, we're going to focus our attention to the flight hours dashboard to begin. And essentially what I'm going to do is help walk you through each of these charts and the functionality behind them. First, we have the flight hours heat map. Now, this shows us the number of flight hours year to date for different counties in North Carolina. You're able to select the year that you would like to view, but it is always defaulted to 2020, or the current year essentially, when loading the dashboard. But you can change it to take a look at years previous and look at different trends in the state or different regions. But we're going to go ahead and leave it at 2020 for right now because that is the current year, and that's what we're going to take a look at for this example. And you're also able to hover over the county that you would like to view, and it will tell you the exact number of flight hours year to date for that county. For example, I live in Boone, which is in Watauga County, right here. And we have 951 flight hours up here in the high country so far. And actually, that is the least amount of any county we have on record so far this year for North Carolina. But as for my parents, though, they live in Forsyth County, and they have had 1,318 flight hours this year. So I'll be sure to let them know that if they want to be beekeepers, they might get more flight hours on average if they stayed in Forsyth County. This chart is interesting to me because it shows me how elevation could also come into play with regard to flight hours. And notice that the brighter yellow signifies more flight hours versus the darker green signifying a fewer count of flight hours. Below that chart, we have the running total of weekly flight hours for the year by week. The legend for the two bottom graphs here is in the bottom right-hand corner. The green line will always be the previous year, and the yellow line will always be the current year. The black line, however, for this chart is the 5-year average running total. This is a feature added to better visualize how different the current year's flight hours are versus the previous 5 years. Again, if you are able to hover over a point on the chart, and it will show you the county, the week number, and the flight hour running total up to that point. You can then hover over the black line for the same point and see the average running flight hours as of that week for the past 5 years. Now, before we go any further, I do want to mention that you can select any county that we have available from over here. So notice how all of these examples I am in Watauga County, but I can change that to take a look at Forsyth County. And it will change every single one of these charts as you see it here, except for the heat map. Now, back to the charts. In the bottom right, we see our weekly flight hours chart. Now, what this is plotting is the sum of flight hours for any given week along the year. It is also showing us, again, the 5-year average flight hour line, but for any specific week of the year. This chart has always been my favorite, really just because we could start to see here not what we define as seasons, but what the bees define as seasons. And last, but certainly not least, above we have the flight hours control chart. Now, this chart helps serve as a management decision indicator for beekeepers. Let's dig into it a bit. The narrow line here in the middle with the dotted red bands represents first 100% of the 5-year average for a given week, while the lower band represents 70% of the 5-year average and the upper representing 130% of the 5-year average flight hours for that week. Now, it's our hope to use this that we will be able to help aid in management decisions for beekeepers based on this chart. For example, if the current year drops below 70% of the 5-year moving average in the spring, like it does here, and yes, about there, it might be wise to inform the beekeepers to supplement food for those weeks as the bees were not able to fly as frequently as in previous years. It is also important to note that the flight hour variability with regard to the different seasons, and we could see drastic changes in the colder parts of the year. But once the weather warms up and the days are longer, we see more consolidation around the 5-year average. Now, we've talked about flight hours a little bit, but let's take a look at the cluster hours side as well. All right, finally, we have our cluster hours dashboard. Now, I'll keep this brief because as you can see, it is almost a mirror image of the flight hours dashboard. The functionality remains the same, but we can see how the charts change a bit. This is because on this dashboard, we're essentially measuring hours that are less than 10 degrees Celsius. We can see the change most notably in the weekly cluster hours chart down here, as it is almost a direct inverse of the flight hours chart on the other dashboard. We can see that we have more cluster hours in the colder weeks as compared to the warmer ones, which is as we should expect. And when I first took a look at this location, we could see that the cluster hour running total is less than the 5-year moving average. This suggests to me that possibly this year could be a warmer year as compared to other years. Even more interesting is when we take a look back at the flight hours chart here, there are fewer flight hours this year as well, which suggests that the temperature increases could be causing drastic weather fluctuations or patterns that even though if we're getting warmer and on average, there are fewer cluster hours, it doesn't necessarily mean we will gain more flight hours, as flight hours depend on other aspects such as rainfall, wind, sunshine, etc. We hope to explore the different aspects of this project with further research down the line. And it is really also our hope to scale this product out first to the United States and then on to the world to have an auto-updating dashboard for beekeepers to reference whenever they might need to. I, for one, have found this project to be a challenge that I was excited to take on, and I am excited to hear any questions that you might have for us. But before we go, and with a little help from Dick, I believe we have a few closing remarks.
Thank you, Manny, for the great explanation and demo. Right about now, you might be asking yourself, what is the value of this tool to me and other beekeepers? In fact, there are many practical uses for daily, weekly, monthly, and yearly trends in flight and cluster hours. Some examples include 1. Predicting what is happening inside the hive. Things like predicting first egg laying, or first appearance of drones, or opportunities for cleansing flights, and more. 2. More precisely defining seasons and identifying when the seasons change, from a bee's perspective, of course. 3. Determining when adequate pollination of crops has been achieved. And 4. Improved planning for seasonal management and pest control, so timings and tasks are more efficient and effective. The Flight and Cluster Hours tool converts readily available weather data into weather from the perspective of the honeybee. Even small temperature changes or different trends and patterns of rain and wind can affect honeybee flight and clustering. Once we have the tool refined and validated, it should be directly useful to beekeepers, but also to researchers. The current objectives were to develop a tool that could be used to validate the flight and cluster hours concepts, and to pave the way for future research. For next steps, we envision flight and cluster hours visualizations as interactive, real-time global heat maps, and we will work toward this result. Also, the topic is perfect for graduate student research and publications. We propose to make all discoveries and tools available to anyone with an interest in this research. We hope the tool that Manny and I have presented here today will get you excited about what can be learned about weather impacts from the perspective of the honeybee, and what might be possible by using the honeybee as a bioindicator of climate change. In conclusion, we feel that we have learned a lot about weather from the perspective of the honeybee. Now we just need to apply these learnings and take advantage of the potential of bee weather to help us manage honeybee colonies better and explore what the bees can tell us about the climate changes happening in our world.